Hello everyone and welcome to this video. So in this video we would we'll continue our next step in the pipeline, which is data pre-processing with TFX Transform. So let's go into our Kubeflow pipelines. So what we are going to do in this video is just feature engineering, right? So we will be transforming, we'll be scaling our numeric features. So here in this TFX transform, you would have to actually look at the statistics of your data and then see which features are numeric and which features are categorical. So we'll scale our numeric features between 0 and 1, and then we will one-hot encode our categorical features. So we'll be looking at this side by side. And so because we'll be working and looking at the statistics, I have put our code and then the pipeline dashboard side to side so that I can refer to my statistics whilst I'm also coding. So the first thing we are going to do is to so we'll be working with the small data set now. So the first thing I'm going to do is I'm going to comment out the temp directory that we used in the previous video. I'm also going to comment out the bean pipeline argument. So go ahead and comment out the bean pipeline argument. And then also the previous video, we passed the bean pipeline argument to this create pipeline function. So go ahead and remove that. And yeah, I think that will be it. We don't need to do anything else in the pipeline component. Okay, so let's go ahead and then write some code, right? So the first thing I'm going to do is so let me see. Yeah, so we are going to start in the pipeline component. So the first thing I'm going to do is I'm going to import. So I'm going to say from tfx.component import transform, right? So it's transform, right? And then I'm going to use that transform component here just after the validator component, and it's going to be transform. That'll be transform, and then the input to transform is we have examples. That'll be example gen dot output examples, and then it also takes a schema. So schema gen dot output schema, and it also takes a model file, right? So the model file will contain our transformation. So we have a model file which is I'll call it census transform model file, right? So we are yet to define what this model file is. I'll just go ahead and do components dot append transform, right? So what will this model file be? So this model file will be a Python file. So you can go ahead and then create a Python file. I have already created a Python file here, and I've named it census transform. So that will be the Python file I'm using. And then I'll go ahead and then define that census transform model file here. So I'm going to say census transform module file should be equal to census transform.py, right? So this is the model file that I would define all my transformations in, right? So with that, we can go ahead and then now write the transformations, right? So the first thing I'm going to do is because in this transformation we are going to use TensorFlow and then TensorFlow transform a lot, right? I'm going to say import TensorFlow as TF and then import TensorFlow transform as TFT, right? So TFT is a standalone library, right? And then so now let's define all our numeric features, and then also let's define what our categorical features are, right? And then so the first thing I'm going to do is I'm going to define all my categorical features. Or let's start with defining all our numeric features first. So I'm going to create a list, numeric feature keys, I'll call that, and then I'll create a list. So the first numeric feature key is age. Now with age you can bucketize your age, right? Put your age into different bins, maybe from 0 to as you can see it's like from 0 to so from 7 to 24 will be one bin, 24 to whatever is another bin. But we are not going to do that. We are just going to do simple transformation. So we are going to scale all our numeric features between 0 and 1, and then one hot encode all our categorical features. You can do more transformations if you want, right? So the first is age. The second one we have is capital dash, so it's a hyphen, gain, not an underscore. The third one is capital loss. The next one is education num, which is in quotes. The next one is final weight. And then what else do we have? We have hours per week. Right. And then that. Okay, so we have 7 numeric features, so including label, but we will not add label to this, so we only have 6 numeric features because we will not transform our label. And then the next one that we have is the categorical features. So I'm going to call it vocab feature dict, right? Because we have to convert this into some vocabulary and then convert it into integers and then one hot encode this categorical features, right? So the first thing so there's the first categorical feature is education, and education has 16 unique values, so that will be the size of our vocabulary for education. So for education, and so I'm specifying this, so I have a key and a value pair 16, and then marital status is 7, and then we have marital status is hyphen, not an underscore, and then we have native country, right? Native country is also 41, and then the next one we have is occupation. So we have occupation, that's 15, and then we have race is 5, and then we have relationship, that's 6, and then the next one is sex and work class. So sex is 2, and work class is 9, right? So how many of that do we have? So that's at 8. 1 2 3 4 5 6 7 8. Now I understand you can write a Python program that will read the headers of your data set, and then yeah, you can do that if you want, but yeah, this is also fine by me. The next one, we are going to define a variable called num out of vocabulary buckets. So it could be that maybe when you see the like, if you look at marital status, there is a domain of value, so maybe married or single or separated or things like that. But it could be that we could have a data set when we are doing the prediction that might not be in the domain of this, but we still want a way to transform it. So you give some out of vocabulary, so you have to give some adjustment to the number of vocabulary so that your feature transform can still transform your data even if you have a value which is not in the domain of your category, right? So for example, education, maybe you have somebody who is uneducated. Maybe you don't have uneducated in your training data, but you still want your feature transformation step to be able to transform that uneducated and then give some output value, right? So I'm going to set my num of out of brackets to 2. So then you have that flexibility of your transformation pipeline being able to transform other values which are not in the domain of your categorical features, right? And then I'm going to specify the label key. That is label. And also I'm gonna so when I do the transformation, I want to change the name of the header or the column, so that I would know which of my columns are transformed and which of them are not. So the first thing I'm going to do is, if there is a hyphen, if the header name contains a hyphen, I'm going to replace that with an underscore, and then I'm going to add the string xf to it, so that it shows that this is my feature that I transformed. So what do we have to do next? So the next thing is to actually use these constants that we defined in our pipeline step, right? So the first thing, So the next thing I'm going to do is to actually write, continue writing stuff in our transform feature. So in our census transform, so let me see, what do we have to do? So yes, so if you have watched my previous videos on TFX Transform, I mentioned that every transform Python model file should have a preprocessing function, right? So we are going to define our preprocessing function, and then here is inputs, right? So the data will be read, and then the inputs correspond to the columns of my data set, right? So actually we don't need that anymore, so we can just make this large, right? Okay, so the first thing is we have to specify the outputs. So what will we be returning? We'll be returning a dictionary, and then we have to look through all the keys, right? So I said we have to scale our numeric features between 0 and 1. So I'll say for key in numeric feature keys, and then I'll say scaled is equal to TFT. So this TFT function, there are a lot of TFT functions, right? So you have TFT bag of words, packetize, apply vocabulary, so many hash strings. So yeah, things that like this will make your feature transformation easily. So we are looking for something scale. So we have scale to 0 and 1, right? And then inputs, and then key, and then outputs should be our transformed name, key, and then we want to flatten our scale to a one-dimensional vector. So we have tf.reshape scaled -1. So this will just scale everything to one-dimensional. And then we do the same for the vocab feature dict, but remember your vocab feature dict is a dictionary, so you need your key and your value. So we say key and then vocab size in vocab feature dict dot items, right? And then so we have to convert all our vocabularies, right? We have to get some indices of all the vocabularies. So we say tft dot compute and apply vocabulary, and then inputs dot key. Now I'm going to leave the documentation for tft, and then you can go ahead and then read what the compute and apply vocabulary does, what scale to 0 and 1 does, so that you have a better understanding from the documentation, right? And then we have num out of brackets, right? And then after that we one hot encode this. So we have one hot, so we have tf dot one hot indices, right? And then what will be our vocab size plus number of packets. And then we also have to flatten this. So output transformed name key, this will be tf dot reshape one hot So this is -1 vocab size plus num. Right. So with this we have scaled our features, our numeric features between 0 and 1, and also one hot encoded categorical features, right? The next thing we have to do is we have to cast our label to float, right? So we have output transform feature name label key, that's tf.cast inputs label key. We want to cast it to float 32, so we say tf.float 32, and then what we have to do is we have to return outputs, right? So we are done writing our transformation function. So I'm just going to go through this to see if we have any errors. No errors. And then yeah, I'm going to go to my pipeline. We've written a transform, no errors here too. Let's go to the Kubeflow dark runner and then run this pipeline. Oh, so one more thing. Also, when you get to the data part, you make sure that you are using /data now. In the previous video, we were using /big data. Now we are only working with a small data. So make sure you are using /data, right? The next thing we have to do is we have to run our pipeline. But before we run our pipeline, so I have to talk about this and the problems with Windows when you are running TFX pipelines. So Windows has a lot of problems when you're using TensorFlow. Sometimes it doesn't just work, it just breaks. And so one problem with reading data from cloud storage is that sometimes on Windows it tells you that the cloud storage format is not implemented. So for example, here we are reading data from Google Cloud, right? So where is that? So we have GS. If you try to read this, it tells you that the cloud storage is not implemented. So why do we have this problem? Because now we are reading data with TensorFlow, right? So the we are not reading data with TensorFlow. So the inputs transform, it's not being read by TFX anymore. So we are now reading data with TensorFlow. And yeah, so that issue is there with Windows. If you're on Linux, you don't have that problem. If you are using Mac, I don't really know. But for Windows, you have this problem. So therefore, I cannot run this pipeline with my command prompt anymore. So from this video on, we are not going to be using our command line, the Windows command line, to run our pipeline anymore. So I have an Ubuntu subsystem for Linux already installed on my computer. So if you are using Windows, you can install Ubuntu subsystem for Linux, and you can use that to run your pipelines. Another way is that you can also install Ubuntu if you want. Another way is that you can also set up a virtual machine. I already showed you how to set up a virtual machine. You set up a virtual machine, you install Ubuntu, you already have Python, you install TensorFlow, you install TFX, you install TF, you install KFP, you get you clone your repo into your virtual machine, and then you can run your pipeline, right? That's also another approach. But I'm just going to go ahead and then run the pipeline now with my Ubuntu subsystem for Linux, right? Let me know in the comment section if you need help installing Ubuntu subsystem. I can just leave you a link and you can follow that to install. Or if you're having problems yeah, just leave some comments in the description. Sorry, just leave some comments, and then I would reply. And so I'm in my Ubuntu subsystem for Linux. So the first thing I've already installed TFX and TensorFlow here. So the next thing I have to do is I have to set my environment variable, right? So this Google application credentials, I have to set that. But now because I'm using Ubuntu, I don't have to set the home anymore. So I have to set this Google application credentials. Here I don't use set, I have to use export, right? I say export Google application credentials, and because I'm already in the folder where this files are located, right? So I don't. And then the next thing that I have to now do is to actually just do Tfx Pipeline Create. So I'll go back here to Tfx Pipeline Create, click enter, and then let's see what happens. So it says creating pipeline, detected Kubeflow. Yeah. Adding components. Yeah, so the pipeline has been successfully created. So now let's go into our pipelines and see if it's there. So we have this, it's over here. So I'm just gonna create so as you can see, the transform has been. So how will this pipeline run? So you see that statistics gen depends on CSV example gen, right? So CSV example gen will run first. We have statistics gen running, and then after statistics gen runs, example validator depends on schema gen. So schema gen will now run, right? But after schema gen run, example validator and transform can be run because they don't depend on each other. The components they all depend on have already been run. So example validator and transform can run independent of each other. So I'm going to create a run for this. Hopefully there wouldn't be any errors. And then click start for that. And yeah, I'll come back when this has run or there has been any errors. So everything ran successfully. There were no errors. So we can go ahead and then see some stuff. So yeah, don't worry about this. This is nothing. Let's go ahead and then look at the metadata. So this is very important. So you can see that the input to our transform was the examples and then the schema, and then the output. We have a lot of output. So transform examples, post transform anomalies, the transform graph, which is very important, which will be used for performing inference on new data sets when we are doing predictions. We have post transform stats, like, yeah, so many things. Yeah, you can even look at we have you can look at the overview. So this is our lineage explorer, right? So from the examples and the schema, you had your transform components. Your target was some examples related to your transformed features. So go ahead and then explore the different especially the metadata that you have, and then yeah, try and then see if it makes sense to you, and also try and explore the lineage of all your artifacts also. And yeah, so we can also look at the lineage of let's look at the lineage of the this thing is really slow of the example validator here. So if you go to ML metadata, so you have your outputs here. Yeah, so yeah, and so basically this is how you would write your components from CSV example gen to transform. So I encourage you to just explore the different aspects of your pipeline and then the artifacts, try to make sense of what the components mean, Google stuff, and then learn. And yeah, in the next video we'll start now with a so the next video will be quite long because we are going to start with a very important transformation. So we are now going into model training, and the model training will start with tuner. So this is a new component that I didn't talk about in my previous videos. So with the tuner, we are going to select the best hyperparameters for our model. So we'll actually build the model in our tuner and then select the best hyperparameters using grid search, and then we will pass these best hyperparameters to trainer and then train our model. So yeah, I don't think I have anything else to add. If there is anything else if I remember it, I'll talk about it in the next video. So just keep watching.